Hello everyone, welcome to Math Enthusiast channel. And for today's video, we will be solving this nice integral suggested by Inf Series Bot from Twitter. And this integral is given as j is equal to integral from 0 to pi over 2 of tan x over e raised to tan x minus 1 dx. So now, if you would like to try it first, then you may consider to pause the video. So, in order to solve this integral, we will be first doing a little bit of substitution there. So, if we let's say let j is equal to tan x, then dj is equal to tan squared x plus 1 dx, or we can also say that dj is equal to dj over j squared plus 1 is also equal to dx. We just substitute the value of this, and this is equal to z, so tan squared x is just equal to z squared. So now we have this dz over z squared plus 1. So now if we substitute this to this integral, then our j is now from 0, since tan of 0 is 0, and limit as x approaches to pi over 2 of tan x is just equal to positive infinity. Now we have this, so this is a over z squared plus 1 times e raised to z minus 1 dz. So now we have this is z. So we will just doing some partial fractions there, or partial decomposition. So if we decompose this denominator, we will have from 0 to infinity of z. If we factor z squared plus 1, this is just equal to 1 plus I times z times 1 minus I times z, and e raised to z minus 1 dz. A over 1 plus ij plus b over 1 minus ij times 1 over e raised to z minus 1 dz. So by partial fraction, we will just multiply the denominator of b to a and the denominator of a to b, and it is like this: a times 1 minus ij plus b times 1 plus ij, and we will just include this variable z is equal to z. So when ij is equal to 1, then we will just substitute ij is equal to 1, then a 1 minus ij is equal to what? 1. So 1 plus b 1 plus 1 and this is if we um, divide both sides by I, then this will z will be equal to 1 over I, or negative I. So negative I, and 1 minus 1 is 0. 0 times A is 0, so this will be cancelled, and our B will be equal to negative I over 2. And for the second case, when Ij is equal to negative 1, then 1 minus Ij is negative 1, then this will be negative 1, and B times 1, and Ij here is negative 1, so minus 1. And if we divide both sides by I again, just like the here, and this will become negative 1 over I, and negative 1 over I is just equal to positive I. I is imaginary root, don't forget that. So this is equal to I, and this will be 0, and 1 minus negative 1 is just equal to 2, and if we divide both sides by 2, this will be equal to A is equal to I over 2. So now if we substitute those values A and B to this integral, then our integral J will be equal to I over 2 of integral from 0 to infinity of 1 over 1 plus Ij minus, this is just equal to 1 over 1 minus Ij times 1 over e raised to j minus 1 dj. And by substituting there a little bit, let k be equal to let j is equal to 2 pi k, and dj is equal to 2 pi dk. Then now we have j is equal to 2 pi I over 2 times integral from 0 to infinity. The upper limits and lower limit will not change, since if this j approaches to infinity, and infinity over 2 pi is just equal to infinity, since it is a very very large number, and we do not know if its exact value, so this will be infinity, and 0 over 2 pi is just equal to 0. So now we have 1 plus 2 pi I k minus 1 over 1 minus 2 pi I k times 1 over e 2 pi k minus 1 dk. And by simplifying this, 2 will be cancelled, and we are now left with pi times I of integral from 0 to infinity of 1 over 1 plus 2 pi I k minus 1 over 1 minus 2 pi I k times 1 over e raised to 2 pi k minus 1 dk. And by using the so-called Abell Planar formula, the Abell Planar formula is given as Abell Planar formula. It is given as sum from n is equal to 0 to infinity of f of n f of n is equal to integral from 0 to infinity of f of x dx plus f of 0 over 2 plus I times integral from 0 to infinity of f of ik minus f of negative ik over e raised to 2 pi k minus 1 dk. So here, this is the Abell planar formula, and if we apply this formula to this integral j, then look at this carefully. So our f of so our function here will become f of ik will become 1 over 1 plus 2 pi ik, and here if we get the f of negative I times k, then our f of negative I times k will be this term. So f of negative I times k is equal to 1 over 1 minus, this is minus 2 pi I k. So now notice we can now use the Abell planar formula to this integral, and if you use this, our integral would look like this: j is equal to pi times sum from n is equal to 0 to infinity. Our f of n, we will just change this ik to n. So our f of n will be 1 over 1 plus 2 pi n, and for this integral we will just transpose these two terms to the other side, and this will be negative. So negative integral from 0 to infinity of f of x, we will just again substitute ik as x. So this will be 1 over 1 plus 2 pi x dx, and for this initial f of 0 over 2, this will become 1 over 1 plus 2 pi n times 2 when n is equal to 0. So if we simplify this, this will be this will become pi times negative 1 half plus 1 over 2 pi sum from n is equal to 0 to infinity of 1 over n plus 1 over 2 pi. And for this integral, if we integrate this will become ln of x plus 1 over 2 pi over 2 pi from x is equal to 0 to x is equal to infinity. And now this will be negative 1 half plus negative 1 half plus 1 over 2 pi. If we take if we instead do this if we instead take it as a trivial, let's say this is limit as k approaches to infinity, say like this. So this will be k, and n is equal to 0 of 1 over n plus 1 over 2 pi, and this we will just copy this again. So this will be ln x plus 1 over 2 pi over 2 pi from x is equal to 0 to x is equal to infinity. And by simplifying this, we will now have pi times negative 1 half minus ln 2 pi over 2 pi, and by using the definition of the gamma function, so I introduced the gamma function on my solution on Facebook, so feel free to check the link below the description. So here we will use the gamma function here to evaluate this summation, and we will now have the gamma one over 2 pi over 2 pi, and since these terms are these terms are having both a divergent term, so if we use the L'Hopital's rule here, then those terms will be just equal to 0. So this will be now our final answer. And by simplifying a little bit here, our final answer will become negative pi plus ln 2 pi plus the gamma of 1 over 2 pi over 2. So now this is our final answer to the problem. So if you like this video, please consider subscribing to my channel, and don't forget to like this video also. So this is now our video for today. So thank you and God bless you.